Hey guys, here is your introduction video to inscribed angles, or for inscribed angles, and let's start with something we already know. We already know the central angle, I hope, and the central angle here is the central angle because the vertex is actually the center of the circle. Okay, so our central angle here just happens to be 102 degrees. Obviously, I can move that around; it doesn't really matter. Or 114 now, and we know how that relates to our arc, because our arc is exactly the same as our central angle. So arc CA, which is here, is the same as the measure of angle ADC, which is the central angle. No big deal. But my question is, what about this inscribed angle over here? See angle B? Angle B has a vertex on the circle. That's inscribed. That's what that means. And notice how it's hitting the same spots that the central angle hits. It hits A and then it hits C. So it's hitting that arc. But this angle B is not 114 degrees. If you looked at the notes already, you probably already know what it's going to be, but let's measure it just to be sure. If I measure angle ABC, it's very interesting what it actually becomes. Measure angle, check that out. It's definitely not 114, but it's 57. Well, it's no coincidence, 57 is exactly half of 114. Okay? Another easy way to see that is, what if I try to make this perfectly straight here? I'm going to turn that into a diameter. Okay? Angle ADC is now a diameter, so it's 180 degrees. And look at the arc that we hit. The arc we hit is 180 degrees, but look at the angle. That angle is 90 degrees. That's a right angle. It's exactly half of the 180. Inscribed angles are always half of their intercepted arc. So don't mix that up with central angle. Again, central angle is exactly the same. Okay? It rounded here. That's why 46 times 2 is not 93, but these numbers are rounded a little bit. Let's see. Let's make it so it's more obvious. How about something like that? I have an inscribed angle of 26. I have an intercepted arc of 52, which means, of course, my central angle is also 52. And I can move this vertex around, and nothing's going to change. Unless I change the measure of the angles, the relationship stays the same. All right, so how does that work when you have to actually solve the problems? Let's take a peek. Oops. Let's try this instead. Okay, I believe you had an example on your worksheet on the notes walkthrough that looked something like this. You had a circle. They gave you this angle is 50 degrees, and they wanted you to find this arc here. Okay, it was something like this. I believe it's example 1 from the worksheet, but either way, we can do it. This is the arc I want. This is the inscribed angle that I've got. If the inscribed angle is 50, then this arc has to be 100, because that's 2 times 50. Okay, the arc is always double the angle, the inscribed angle, or the inscribed angle is always half the arc. Just depends on which way you need to go. If I gave you the 100 first, then you would have just divided by 2 to get the inscribed angle. If I give you the inscribed angle first, then you just multiply by 2 to get the arc. Okay, let's do one a little more complicated. In fact, I believe I'm just going to pull it right from the worksheet, because this is kind of a tough one. It's kind of hard to see. I'll draw it a little bigger here. This is 8x plus 10, and this is 12x plus 40. So you can see, if you compare it to the example we just did, it's kind of the same idea, but there's just a little more algebra involved. Okay, if you think you have an idea how to solve it, why don't you just pause the video and see if you can get it. But then I'll go ahead and solve it too. Okay, so pause the video right now, try to solve it, and then if you get stuck, play the video, or when you get your answer, play the video and see if you got it right. Alright, so here's the inscribed angle, 8x plus 10. Here's the intercepted arc, 12x plus 40. And you can look at this two ways. You can look at it as, I need to divide this by 2 to get this one, or I need to multiply this by 2 to get that one. Whatever's easier. In this case, honestly, it probably works just as easy both ways, because these numbers, it works nicely with the divide by 2. But you know what? If you want to play it safe, multiplying by 2 will always, you'll never have to worry about fractions or decimals, which I know how much you guys love those things. So if I take 2 of these, I should get 1 of these. It takes 2 of these to make 1 of those. Then you just got to be careful, make sure you distribute. 16x plus 20 equals 12x plus 40. I'll bring my 12x over here, that gives me 4x. I'll bring my 20 over here, that gives me 20. And if you're wondering how I got that, I just subtracted, subtracted again, and then of course x equals 5, right? Divide by 4. If x equals 5, we can put that back in and check. If x equals 5, this is 8 times 5, which is 40, plus 10, so that's 50 degrees. And if x equals 5, this is 5 times 12, which is 60, plus 40, which is 100 degrees. Pure coincidence that it was the same numbers as what we did over here. But that's how that works. Okay? So the inscribed angle is always half of the intercepted arc. The inscribed angle is always half of the intercepted arc. That's how you pretty much solve the majority of these problems. Okay? In the next video, I will talk about the inscribed quadrilateral, but this should be enough to get you through most of the problems. Okay? Let me know if you have any questions, post them on Edmodo, and I will talk to you guys soon.